So we have 4 molecules right now, and we want to know each one of them are going to be subjected to an SN2 reaction. So these are all your electrophiles with your leaving groups touching them, right? So the question is, which of these is going to react fastest, and then which one of them is going to react slowest? Okay, so let's think about this. The actual shape of the electrophile, that's a big fancy word or big fancy term for what? Is the electrophile primary, secondary, or tertiary? What's the best case scenario for an SN2 reaction? We want it primary. We want small. All right, so here you go. So let's look at all of these. Point being is that we have to classify each one of these ones. So let's look at A. How would we classify A? Again, I'm going to do it just for the first one, and then I'm going to see if you guys can kind of get the gist of this afterwards here. So this is our leaving group is right there. The leaving group is always touching the electrophilic position, and the electrophilic position is touching how many carbons? 1, 2. So this is what? This is a secondary Rx, okay? Go to the next one. Oops. Go to the next one. All right, so B, how would we classify that electrophile? This is tertiary, okay? Okay, C, primary, excellent. And then finally, D, also primary. Okay, cool. All right, there's a little puzzle to understand here. All right, so let's see here. Which one of these is going to go? Let's go with the easiest one first. Which one's going to go slowest and why? Tertiary. B is going to be our slowest one. Why is it the slowest? Steric bulk around the electrophilic carbon, right? So we think about that carbon as being that blue right there. You have 1, 2, 3 carbon groups that are surrounding it. And it's going to be hard for a nucleophile to get in and do a backside attack to that blue position right here. So that's going to be very, very slow. In fact, it's so slow we just generally say it's non-reactive. All right, so that's that. All right, so that's the slowest one. Which one's the fastest? You have 2 of them. One is more faster than the other one, slightly. Which one's more faster, C or D? She says D is a little faster than C. Why is D a little faster than C? Less crowded. So even though we're not necessarily talking about, love this problem because it really emphasizes who's paying attention. If you know where the electrophilic position is, you know that these things obviously have, these things obviously have one group touching the electrophilic position, but here's the deal. What's touching that one group that's touching the electrophilic position? I've got 2 groups here, and I only have 1 group that's right there. So yet again, this is a steric effect that's actually influencing this. So if I were to classify this, I would say that this is probably going to be your fastest. So as you take those bulky groups, those methyl groups, and you move them further and further and further away from the electrophilic position, the reaction rate will increase. And as you move them closer to the electrophilic position, you'll slow the reaction down.